Andre. I'm an incoming assistant prof at IIT. Therefore, the new logo, I managed to get rid of Kyle. But still I'm here. And this talk is more or less kind of further talk about Globus Compute and a little bit of shameless self-promotion, because we were publishing a Dataset journal paper, and we just want to dive a little bit into this dataset. We heard a lot of Globus Compute. Basically, I want to go a step back. It works with serverless computing. Why do we use serverless computing? Serverless computing has a few kind of advantages. One of them is like we can run applications without thinking about the hardware or the infrastructure. So I can say I pick a runtime. I will take Python as an example because that's Globus Compute use. When I write a function, let's say hello world, and we can just run and forget about it, and the platform is doing everything by itself. It has some advantages, like it's on demand, it's elastic scaling, pay as you go, it's super fine granular, so it's better than, for example, FaaS, IaaS, or SaaS. And we have common cloud providers, for example, AWS, Lambda. And when Kyle thought a few years ago, yeah, what is about scientific computing? How could we get this to the serverless community? And so he was working on FunkX here. And meanwhile, it's called Globus Compute because it was integrated in this whole community. And I think it's just copied from the paper back then. The idea is to have a managed federated function as a service for reliable, scalable, and secure execution functions on remote endpoints. And these endpoints can be laptops to supercomputers. I mean, whoever worked with Globus Compute should know this. And why for scientific computing? I mean, we researchers are kind of lazy and we like to work in our bubbles. And mostly with high-level languages. And so the idea was here to allow researchers to work with familiar frameworks and familiar languages without to kind of think about, again, like the hardware or whatever, just do our analysis, run it, and forget about how it's done. Basically, the goal was back from Kyle to move closer to research, to a researcher environment. And so Globus Compute, or for the Globus Compute dataset that I'm going to introduce now, we were collecting data with the help of Ryan here. He sent me a lot of nice files that I had to parse. And basically, we have 31 weeks of data. Here are the hourly arrival rate. You see something is going on here. It's not like a dead platform, something happens. We have in this data set 2 million function calls, about 270,000 functions, and about 252 active users. It was somewhere last year. I don't know what the current status is. Kyle was talking yesterday about it, but I didn't memorize these stats, but it should be increasing. And also we were looking where are the people. For some reason, we have people here in Chicago, we have some people in New Zealand. I wonder who it can be. But yeah, so we have an active community worldwide. We miss some continents, but I think we have a good coverage so far. Why this data sets? I mean, there's for example Azure data sets that also have FaaS capabilities. For example, compared to the Azure data sets, we have really fine granular timestamps. We know when a function was requested, when it was executed, how long it was executed, and everything is in nanoseconds. For example, the Azure one has binned slots. I have now, for example, in 1 minute, 100 functions were executed, but I have no other information. We have a function source code and we analyzed it, so we know what functions were run. And we also have an endpoint. So as it suggested here, for example, we know where was it run, what was the executor, and so on. And so we did some analysis because we want to get or provide the community with some information. For example, we were interested about the system's performance. How often were requests submitted? We were interested, for example, how do we have power users? How are the tasks invocated and so on? And we also analyzed the function bodies. You will see it in a second. We're interested in user behavior and we're looking, for example, at different patterns. Are there, for example, recurring users or users that have some spikes and then don't do anything anymore? We were looking at cold starts. And for example, we clustered all these functions. We had, in the end, I think 47 clusters. We did a manual kind of cluster of 47, and we came up with these things, for example, class of functions that are run on Globus Compute. So for example, we have machine learning based, we have trivial ones that do data manipulation. So a lot of different stuff is going on the Globus Compute platform. We also looked at statistical analysis. So for example, on average, we have 403 requests per hour. It ranges sometimes from 0 until to 10,000 of requests per hour. So it's a really volatile platform. Everything is in the paper. You don't have to look here. It's just like a copy of an even longer table. So what did we do besides the statistical analysis? I mean, we had different interests. So for example, we were looking about end-to-end time. So I submit the function until I get a request. On average, it's 23 minutes. That sounds quite long. But if you look, for example, at some different perspective on it, 85 of the functions were completed within 10 seconds. It means you have really long tail running functions. And so it's kind of interesting that we have really short-lived functions, but really some take up for ages compared to 10 seconds. And we were also looking, for example, how could we set a warm time? So keeping, for example, the functions alive without spending it after their usage. And if you would say 5 minutes is a good kind of cutoff, we could keep 93% of the functions warm and avoid therefore cold starts. We're also looking at what are most common libraries used. For example, NumPy is quite often used. Based on this information, we had a paper recently at eScience, if someone wants to read in it. We were looking at, for example, the endpoints. We had like local ones, some driven by Slurm or Kubernetes. And I'm going to finish because I hear the timer. So why we did this data set of analysis, we wanted to help researchers with serverless computing specialized for scientific computing. So we did a lot of different analysis. Again, 31 weeks, 2 million functions. We had really fine-grained data, timestamps that is, for example, unique compared to Azure data sets. And we tried to be fair, so findable, accessible, and so on. The data set can be found here at a QR code. And we want to do it in a rolling manner. So we plan already to release a second version because more than a year passed, we hope to provide then even more information. So far, everything from me.